Good morning, or good afternoon, or good evening, whichever is appropriate in your part of the world. My name is John Kohlhaas. I'm the Director of Operations in NORR's Philadelphia office, and I'm very pleased to welcome you to the fourth lecture in our 2021 NORR Ed season. I had the opportunity last week to get a little preview of today's lecture, and I think you're really in for a treat. A shout out to our NORR team in all our 13 worldwide offices in Canada, in Toronto, Ottawa, Calgary, and Edmonton, in the US east to west, Philadelphia, Detroit, Chicago, and Sacramento, and finally in the UK, in London, Cambridge, Newcastle, Glasgow, and Inverness. This opportunity for us to be together, to learn together, is an important part of our ongoing efforts to bring the best talents of a global team to bear on the issues facing our clients. NORR Ed is making a special effort this year, not only to break down the barriers within our own firm, but to reach out to our colleagues in the industries and the universities that are preparing the next generation of architectural engineering and interior design professionals. So today, I'd like to recognize the University of Roma Tre, the University of Calgary, University of Waterloo, the Royal Architectural Institute of Canada Syllabus Program, Drexel University, and Temple University. We want to extend a warm welcome to the students and faculty members that are joining us today. We hope you will enjoy this and spread the word. Finally, for those that need AIA credit or AA credit or AAA credit, we will be sending information to the attendees that are here today in the near future that will provide information for self-reporting. So now I'd like to turn it over to Silvio Baldicero to introduce today's speaker.
Thank you, John, and a welcome to everyone for this, our fourth NORR Ed. And as most of you know, the NORR Ed, as of last year, was structured in three parts: architecture, engineering, and the master series. And as our fourth May session, this is the master series, which combines today architecture and engineering. Next slide, please. And the next, please. So the session today is about architecture and engineering, or engineering and architecture. And it's one that's very close to my heart, because when you take a look at what we as architects and engineers do, it's hard to separate the two. And I'll start off with a very personal story. I was born about an hour south of Rome in a small town called Sora, and came to Toronto when I was 5. But when I was 12, we went back and spent a number of weeks with my uncle in Rome. And if you look to the left, there's a small building, Il Palazzetto dello Sport, which was designed by an engineer architect, Pier Luigi Nervi. And that building impressed me so much then when I was 12 years old, that I think that it was the building that really struck me, and probably the building that drove me into the profession that I ended up going into for the rest of my life. Pier Luigi Nervi is a name that is synonymous with engineering, but also architecture. It's an architecture that's founded on engineering. And in talking to my good friend Rick Haldenby about who should be presenting Pier Luigi Nervi, it was a natural that the architect that actually wrote the very first book on Pier Luigi Nervi, Paolo Desideri, whose father was Pier Luigi Nervi's partner should be the one to deliver this session. And having had discussions with Paolo Desideri back a number of months ago, we had a number of talks, and having seen the presentation just last week, I think most of you are going to be quite impressed with not only the history of an engineer and an architect, and as most of you know, NORR is about architecture and engineering, and the two are mixed. They're not synonymous. They're not one, but they are mixed. And it is engineering and architecture that we do, and we do extremely well. Next slide, please. Creativity versus extravagance is the session description, and I'm not going to read it. Hopefully most of you have seen the invitation that went out, but what I will go through is the next slide, please. Paolo Desideri is the co-founder of ABDR, Architetti Associati. He has been their managing director and technical chief up to March 2019. Paolo graduated in architecture in Rome in 1980, and in the same year, he has been visiting scholar at the Institute of Architecture in New York in the US. He has been a full professor since 1985 and since 2000. Full professor of architectural design at the School of Architecture at the University of Rome, Roma Tre, where he is coordinator of the doctorate in landscapes of the contemporary city. He has been a visiting professor in many schools of architecture, among them Washington University in Seattle, the Bauhaus, Architecture of Rome, La Spezia, Waterloo University in Toronto. And then from 1998 to 2002, he has been the coordinator of the analysis unit of the Department of Development and Cohesion Policies of the Italian Ministry of Treasury, Budget and Economic Planning. Paolo's design activity is mainly carried out in the public and private sectors of large infrastructure works, museum and cultural public buildings, and large real estate complexes. Paolo has progressively specialized in integrated design and in the control of the relationships between architecture and engineering, with particular attention to infrastructure works, projects, and in particular, railway and underground stations. He has been the author of a number of publications, and as I said earlier, being the author of the very first book that was written on Pier, Luigi Nervi. Our discussions over the last few months have led me to believe that what I've always thought about architecture, not being just architecture, but being architecture and engineering one, both with the strength of each other, and something that we shouldn't forget. And it's something that I think that NORR has been founded on, in sharing the knowledge of architects, engineers, and then leading to the Master Series, which is now part of NORR. And the Master Series is about looking at the greats in the past. And certainly Pier Luigi Nervi is one of the greats. And as Paolo said to me in one of our talks, is that Pier Luigi Nervi is no longer with us, but the philosophies of Pier Luigi Nervi still continue. So with that, I will turn it over for this lecture to Paolo Desideri. Paolo.
Thank you, Silvio. Thank you so much for invitation. And so I propose as a title of this lecture, Creativity versus Extravagance. Really, first time that I understand that there is a big difference between creativity and extravagance is reading private mail between Anthony Tedesco, a very important big North American engineer that was at that time during the 30s just a student in Berkeley, and Felix Candela, the famous Felix Candela. And I find an incredibly clear specification of Felix Candela to Tedesco, and Candela wrote, well, the biggest problem in this at this time is the extravagance architects' dreams. Extravagance architects' dreams. So what the difference between creativity that is, let's say, I think it's our main tool as architect and in general as designer, you know, and extravagance. And personally, I think that the main difference is that creativity is something that we can use, that we have to use to solve our problem. But at the same time, extravagance is something that anytime transform problem in big problem. Let me say that creativity is something to solve problem, and extravagance is something to add problem, to increase problem, let's say. So creativity in certain sense is something that is a common field, let's say, between architecture and engineering. Because in my opinion, the most important common field between these two disciplines, this two approach to the design, that is architecture and engineering, are creativity and forms, that means morphology. And personally, I think that this is the most important contribution give in the history to the Italian lecture, to the Italian as an Italian effort, starting in the Roman period with the classical architecture. In classical architecture, in all the classical architecture, in fact, in my opinion, it's almost impossible to recognize what kind of form became from engineering or what kind of form became from architecture. What an arch is a form becoming from architecture or is a form becoming from engineering? Or you know, the Pantheon cupola is a solution became from Roman engineers or from Roman architects. So in all our tradition, there is a so tight, so strictly connection between architecture and engineering through the form. And personally, I think that this approach is the main heritage of the Italian school. The possibility to find through forms, solution of the to some problem. No? This is Michelangelo, of course, and the previous one is Filippo Brunelleschi. No? And all their forms are forms and creativity solution to big problem, huge problems, no, at that time. In this tradition, personally, that is a tradition that goes on and on through all the Italian history of architecture. I think that a very special period is the period between 50s and 60s, and partially also 70s, with some very important office of guys, of designers. I don't know if they are engineers or architects. People like Sergio Musmeci, that is the guy represented here, or Luigi Nervi, or Riccardo Morandi. It's very particular condition that they was competitors one each other, but all of them was over the same concept, that is the possibility with power materials, with not specific power of material like iron or like steel, like in British tradition. In Italy, we never have industrial revolution, real industrial revolution. We never have a lot of steel. We never have expensive materials of technology. And the answer of the Italian school was exactly like in the period of the Roman arch, of the Roman cupola, or the Michelangelo or Brunelleschi, to find through forms the way to stand up for architecture. This incredible bridge that Sergio Musmeci realized is a bridge realized in Potenza that crosses over a river named Basento. And Sergio Musmeci find this form looking at the possibility to discover the form that ensure the minimo strutturale, the minimum of material, of quantity of material necessary to stand up the street over the spider grid, let's say. And what is incredible is that this form here that became 50 years ago, was completely free form, more and more similar to a spider grid. And like a spider grid, ensure the minimum of structure of material to ensure capacity and resistance to the weight. In certain sense, let's say a way to save energy, to save material, to save quantity, to save money, because at that time cost was specially produced by quantity, not by job of men, because to realize this one, it's in concrete. Imagine what kind of form work would be necessary to realize of this, no? But in sense of quantity of material, this is the minimum necessary. Spider grid, light like spider grid, no? That you can see in the line over. Between Nervi and Musmeci, every time in challenge one each other, there is a special point of confrontation that was in 1969, the competition for the first project of the Messina Bridge, the bridge that crossed over the Stretto di Messina, okay? And in challenge for a bridge at that time, but also in this time, because the idea to realize the bridge like this, 3 kilometers of land, was absolutely unbelievable. No? And what is incredible, Sergio Musmeci won the competition, and Pierluigi Nervi was the second prize. And what is incredible is the both of the project, the proposal, was at the same idea, let's say, that is an idea that through the form, through geometry, you know, produce the solution. And the idea in this case, as you can see very clearly in the right proposal, that is the Nervi proposal, is the cables of the bridge that stay, each one, not in a vertical plane, but in a sloped plane, obtaining through this the resistance to the transversal force, to the transversal tension, very important for the wind in that site. Okay, so same solution that here means to work to stay in these two planes, two sloped planes, is also a solution in Sergio Musmeci bridge that propose a vertical plane for the upper part, but as you can see here, another strap, let's say here, another tensor here that produce an sloped plane in the down part of the bridge. Yeah, this is very clear, you know, the solution. I start with this cross point between Nervi and Musmeci because both these genius of the Italian design of that time for a so incredible competition, let me say again, 3 kilometers of suspended bridge, find same solution in certain sense, no? And same solution is not through technology, is not through hyper materials, no, but it's through forms, the capacity, the ability of form, of geometry to resist and to realize solution, forms and creativity, of course. Pierluigi Nervi is the person on the left, and we will see, I will show you 3 or 4 projects of Pierluigi Nervi, starting with this project that probably is the the first very important project that he realized in 1930, between 1932 and 1937. It's a set of aviorimesse with some different solution. He proposed for the military ministry in different sites. This is in Orbetello, in front of lagoon, for the idrovolanti, the plane that use the lagoon to land, let's say. But also here in Orvieto is a very, it's just with some small difference. Let me explain something as a first introduction to Pierluigi Nervi. To understand Pierluigi Nervi work, it's necessary to understand that he started really not as a mainly as a designer, but he started as a general, as a building constructor. It's a building corporation, let's say, no? That's quite typical of the engineers in at the end of 18th century. The minerary engineers produce a company to extract materials, and railroad engineer produce a company to realize, to build railroad, and a civil engineer like Pierluigi Nervi immediately start with a company to build, to realize. But immediately he understands that the best way to increase his activity as a general contractor, let's say, as a building contractor, was optimize design through creativity. And he started with this idea. This is an brevetto. It's a deposit of a way, of a strategy. The idea was to put together a simple element to realize arch or couples and so on, but using prefabricated element, pre-existing element, just like in a huge play like Lego, to join them. And so this is the first conditioning that he realized of this. And the idea was so incredibly modern, let's say, no? Or contemporary, that is a prefabrication method, but in that prefabrication is specifically dedicated to this project only for this occasion, and specifically produced to solve the problem of this dimension here. So the idea is to realize the huge shelter, almost 50 meters for 110 meters, linking together simple prefabricated element. But these elements are prefabricated on the site just for this occasion. So the construction go on very speedy and very simple, realizing a huge, let's say, pillow of provisional structure. Over this, to place the element, prefabricated on the base of the site, like this. This is the, look at the scaffolding, okay, provisional scaffolding, and all these elements just put one over each other, and this reduce the necessity of concrete, of specific concrete, just here and here and here, and then moving the scaffolding, and the wall stayed. Okay. What is incredible is the very creativity through them. It's possible to realize a so huge shelter, and then the problem is to go down with the weight of the shelter, that is very sloped, and problem is that to save quantity, of course, this shelter is sloped, is not vertical, let's say. It's not an arch a sesto pieno, okay? But it's a very sloped arch. So obtaining in this way a save of a lot of material, okay? But this produces an very sloped weight, and the problem of this, like very clearly in this diagram here, is to go to the earth, not for the vertical weight, but for the horizontal force, to contain the horizontal force. Otherwise, all the shelter enlarge and go out. Okay, so the middle part of the project are the pillars that contain and produce a verticalization, let's say, of the weight, of the original weight. To do that, the first element that he realized is this huge beam here, horizontal one, that take every singular point, the weight produced of every singular point, and obtain the connection with just 1, 2, and 3 elements, 1, 2, and 3. And then in this point here, that is the pillar, more or less there is exactly, this diagram that obtain the as a strut here, and as a strap here, in the form of the pillar. In the different version, these pillars are or like this or like that, no? But anyway, the mechanism, the strategy is every time the same. So this element here consent to go down directly to the vertical component of the weight, and this element here, it's let's say, a strap is a tensor, let's say. Okay, the second project that I want to show you, it's the project that Silvio described in the introduction, is the this very, very particular palazzetto for inside for indoor sports, and this is Palazzetto dello Sport. Dimension of this is 60 meters of diameters. As you can see, the cubo, it's very, very sloped, very, very rebate cubo. It's not vertical, no, like the Michelangelo cubo. If we use a vertical cubo, no, there is no problem, you know, of horizontal component of the weight. Okay, all the cubo go in vertical directly to the ground, but to obtain a save of material, Nervi use very sloped arch, okay, like this, reducing the quantity of material necessary for the cubo. Okay, but to do that at that point was necessary to invent something that I will show you here, you know, to transform the tension to the ground, okay, and to constrain the tension to the ground. This is a view that show you Roma during the beginning of 60, the end of 50s. This is the Villaggio Olimpico. This is preparation for Olimpiade of the 1960 in Rome. And as you can see here, the main part of the realization became from Nervi. Palazzetto dello Sport became from Nervi. This is a fantastic, still now existing stadium that is the Stadio Flaminio. And this is the Corso Francia Viaduct that is also from Nervi. The Palazzetto dello Sport, as you can see here, it's 60 meters of diameter. And also in this case, Nervi produce a solution that provide, first of all, a creative way to realize the huge shelter, the cupola that is here. Then a very important creative mechanism to verticalize, let's say, the sloped spin in this direction, verticalize at maximum, and then contain, and then third, the way to contain the horizontal component of the spin of the shelter. The mechanism is through this incredible 72 pillars on Y form, let's say. Yeah, plans and section, and construction that provide also in this case the realization of a number of huge elements simply added of the pillow of scaffolding, let's say. So preparation of the huge pillow of scaffolding, and then realization on the site of the prefabricated element in concrete, okay, like this. And then realization of concrete of only the junction within every singular element. And then the cobalt, it's gone, okay? Yeah, this is the look at this, the huge element realized on the site is concrete and steel inside. Yeah, they transport in a very artisanal way to the pillow, let's say, and just with one element here in 8 months, more or less timing that today we use for rehabilitation of an apartment. They realized the palazzetto dello sport. Okay. Yeah, this is an beautiful view of the beginning of the work. They start with the realization of the pillars, the slooped pillars, and then realization of the pillow, of the scaffolding pillow. At that time, all the pieces, all the different pieces are ready, and then they dispose just over the pillow the element, and then, as you can see here, they go with the cement, they go with the concrete, that go down just on this element. What is incredible is that this element here are lost formwork. So the internal view that you have here, yeah, is thanks to the elements that are also lost formwork for the concrete that link together any singular element. Okay, like in a play for boys. Yeah. Very special also the pillar that you can see here. First of all, as you can see, any pillar is like a man with open arms, let's say, and the leg that stay over to immediately consent to go down to the vertical component, you know, of the slooped pression, you know, of the cupola. Okay, but problem, of course, is here where this component that is the horizontal component, that is the edge, go here, and it's necessary to contain, to refrain, because otherwise enlarge and the cupola go down. Okay, so to do that, Nervi realized a huge foundation here in pre-stressed concrete. That means a solution that consent to the ring of basement, to the foundation, to work to the tension for all the section, like a huge element of steel. You know? In this way, let's say any singular strap here works 2 times for tension, impriming a pressure to the concrete. But when the scaffolding was eliminated, also the concrete start to work in tension, going to zero, okay, with an incredible save of cost. Last project is the hugest that we have in Roma. This is the Palazzo dello Sport, also realized during the period of Olimpiadi in 1960. This huge palazzo is 100 meters of diameter, and yeah, it's realized through ring balladry that serve the central arena. And as usual, Nervi divided the problem in three parts. First part is the realization of the shelter, also in this case realized through prefabricated element added one over each other and linked together with the concrete. Okay. Then a central mechanism, that is the mechanism through that it's possible to verticalize the spin of the sloped cupola, let's say, and then the basement, the foundation, let's say. So this is some view of the project that is really fantastic and still now used. You can see the shelter here, very particular shelter. This shelter is realized, yeah, thanks the adding of an prefabricated element that is this one, 1, 2, 3, and then 4, 5, 6, 7, 8, and so on and so on and so on. They are just added over the pillow of scaffolding, of provisional scaffolding, linked together to concrete, and also used as a base for all the plans, electrical and also mechanical, air conditioning, or the whole hall. Okay. So this is the cupola that you can see here. And then at the end of the cupola start the problem of verticalized, the very sloped spin, the very sloped weight of the cupola. Problem is every time the same. The idea to go to the foundation with a weight that is almost vertical, no more like this, but almost vertical. To obtain this, as you can see here, he realized this element here that is like let's say a concrete fan, okay, that produce a concentration of the cupola in just in this point, and in this point, in any of this point, he add the weight of the coverage of the circular balladry, obtaining, look at this, no? This is the original component of the weight, but thanks to the fact that in this point he add weight, the result is a verticalization of the weight, let's say. And then again, adding this floor here, another verticalization, yeah, that is this one. And then again, verticalization obtaining this one. At that point, let's say, the spin of the cubo is almost vertical and foundation is very easy. Just this modeling, this morphology to maintain it and constrain the horizontal component, let's say. Yeah, you can see here all the elements. This is the concrete fan, let's say, that go down. And here, yeah, this is the fan. And here in this position, there is this pillar here that produce concentration of the coverage of the circular ballatory. Yeah, look at this. This is the pillar. Okay, this one. Okay, and also in this point is hanging up the chairs floor in this position here. So this pillar here finally is nothing else than the result of the static diagram that I showed you before. Okay, this element here is a huge element. Yeah, this is the realization of the fan, of the concrete fan, of the concrete fans. Very particularly also the glass, that, as you can see here, is just glass without frame, with the internal simple element of glue, of rubber. Okay, and then the pillar. This is a very huge pillar that is exactly, as I show you, the position of the previous loading, of the previous load. Okay, this element here is more or less 5-6 meters, but it's very particularly because, as you can see here, was necessary to have a pillar with a base with a rectangular base here in this direction, and with a rectangular base here in that direction. That because here, the beam was like this, and here the beam was a circular one. So this pillar here is a fantastic, because it's a morphing pillar, let's say, because start with a rectangular in this direction and go at the end with a rectangular in that direction. This is the look at the formwork, incredible formwork of wood, reused for any singular pillar. Reused means that every time was cleaned up and then reused to the other pillar. Okay, and this element was the containing element to the pressure of the water and the concrete. Okay, yeah, this is the image. It is a picture of the site. In the construction of pillars go on, and then at the same time is construction of the floor. Also, construction of the floor was very particular, because this floor here is a prefabricated formwork, reused every time, and this formwork here is a formwork that use this line as a beams. And these lines are the lines of the isostatiche di minima. Isostatiche di minima are the lines in that there is no torsion, okay? And thanks to that, the dimension of the floor is extremely reduced, and dimension of the beam, of course. Okay. So again, a way to solve through the form and through creativity a problem of save quantity of material, okay, of construction in general. Yeah. Okay. So let me conclude the lecture with the 3 projects of mine. This is my office. That's me, and then Filippo Raimondo, that is the R, and then Michele Becco, and then Maria Laura Arlotti. This is the first project that I want to show you. In all these projects, we try to use creativity to solve problem, of course. Creativity, not only in a structural sense, let's say, no, but creativity to solve any kind of problem. It's in front of the designer. You know? The first problem that we have in this project here is the incredible dimension. This is the new central station in Roma, Roma Tiburtina. It's a bridge station that crosses over 25 tracks, and surface, the total skin, let's say, of the station is more or less 3 hectares. So huge problem in sets of you know, heating and refreshing, or huge possibility using bioclimatic similes and in general bioclimatic strategy. This is a very large infrastructure architecture realized at the end of 1910. We won the competition in 2002. We start with the site in 2008, and then we finished and opened the station in 2010. The main, usually I say that the challenge of Tiburtina is in numbers, in dimension. In dimension of numbers doesn't mean only numbers, real numbers, physical numbers, but let me say also in general immaterial numbers, like these numbers here. This is for all the stations realized in Italy in the last 10 years from me, and then Firenze Macelli under realization with Norman Foster, and then Torino with Arep, Bologna partially realized with Arata Isozaki, and then Napoli Afragola with Zaha Hadid architects completely realized. And this is the number of persons that every day go in the station. So a station with 200,000 people that every day go through the station means that this is not only, let's say, a station, but it's also the most important public space that we have in Italy, the most important supermarket, commercial center that we have in Italy, the most important services center that we have in Italy. So something that through the number, the social number in this case, go over and over a specific simple functional problem and invest a problem that is an identity problem. Dimension, in fact, is related with the, let's say, monumental necessity that a so elevated number of persons every day have to recognize in this space, to represent in this space, let's say. This is a monument to Camillo Benso, Conte di Cavour, that was in end of 18th century, the person that unified, the prime minister that unified Italy and realized first piece of tract of our railroad company. And this is the two speeches on the parliament of Camillo Benso, Conte di Cavour. Then we are going up to the gallery that cross over the tracks, and imagine that this gallery is 24 hours a day completely opened, and like in an airport, there is another floor, that is this floor, that is open and closed, but is not every time open, you know. So the problem of this floor is that this floor is realized through these huge, let's say, flying bubbles. You know? These bubbles are flying because they have no pillars down, but they are hung up to something that is on the up. And the reason of this is that, yeah, as you can see here, okay. And the reason of this is that, you know, we have any singular pier, foundation 1, 2, and 3, foundation of the pier, of every pier, but the train produces a terrible vibration, and vibration goes up and find a disaster with any element. So first asking to Massimo Maiovieschi, that was the engineer that with us realized the structure, was what kind of structure can we invent to cut completely through morphology, not through technology, this kind of vibration. And the solution is the clapper of the bell. You know? If you think about of a clapper of a bell, if you gently move the bell, you can see that the clapper stay for gravity and the bell move, but the clapper stay for gravity. Thanks to the gravity, vibration is completely cut. So we go up with these two huge pillars that they stay every piers, and piers are 25, okay? And then there is a huge spatial reticular structure that is also the space for you know, all the machines that stay out of the station. And then starting from here is hanged up anything, the bubbles, let's say, but also the glass, okay? So all the glass is completely cutted in sense of vibration. This dimension here is also useful for simile during the winter and the summer for bioclimatic use. In fact, during the summer, simile are completely opened. So that means that insulation produce warm air that goes out through the simile and ask for new air from outside that go down through this element that simply produce refreshing through a sprinkler of water. Okay, so warm air go inside like fresh air, and continuously there is this loop of passive heating and cooling. Okay, so during the winter the chimney are mainly closed, and so insulation produce warm air that stay. Okay, yeah, this is the final result. Of course, from the right side, every pier there is the possibility to go down. So the bubble are also the ceiling, let's say, or the waiting room to go down. Okay. This is the east atrium of the station, and that's it. The second project is as Multiburtina Station. This is just opened, is a station that we realized with the competition in Morocco, in Casablanca, Casa Voyager. Also here we have for the competition to enlarge the original colonial simple station, very nice station, with a new station for high-speed train that cross over a bridge station like this. This station cross over 10, only 10 piers, let's say 10 tracks, not 25 like in Tiburtina, but we use the same strategy of Tiburtina. This is a completely a bridge that use the spatial reticular structure that is over like a bridge structure and suspend the floor of the gallery, obtaining a completely freedom for the iron plan, for the plan of the railroad company to have to design as they prefer. Some pictures, this is the original preview, the rendering, and this is the realization. This is the rendering, this is the realization. This is a joke that every time we realize at the end of the project to have a confrontation between the original idea and the final realization. And let me say that it's not easy in controlling from Italy to obtain in Morocco and something that is so so strictly same, you know. And as you can see here, the spatial reticular structure go down here, you know, like a huge pillars of themselves. Okay, and this is the east entrance, and here we have the west entrance on the other side, and the cover is open. Another particularity is the use of material. We think that it's very important to use the possibility of local material to cross over the false dialectic between modern and classical, or modern and local, let's say, you know, because the this is absolutely modern architecture, no? But at the same time, through material, I think that it's the possibility to redefine, recontextualize the architecture, the panels that cover like a skin, you know, all the structure is in fact panels realized there with our design that is almost an musharabia, that is the typical local element used in Morocco. Yeah, like this, no? To obtain frame and protection of to insulation. No? And we reuse this idea to have an envelope, let's say, of all the structure that in self is not important to be shown. No, I think. Same attitude is the vertical element, like this. This is also we designed this, and we asked to realize and have a production, a special production. It's a brick, ceramic brick that use the fantastic colored system of the colored ceramic that we have in Morocco. The final, this is the V-plunge of the king, that is, let's say, particular, but very, very simple. No? Yeah, the final result is like this. And, you know, I think that it's a good way to obtain with simple tricks a recontextualization of you know, modern architecture. The third project that I want to show you, it's a very special project in sense, in every sense, because it's a renovation, rehabilitation, and enlargement of a museum realized during the 30s from this famous Italian architect named Marcello Piacentini. This is, imagine that this is the first Italian museum completely realized in concrete, with structure in concrete. But, you know, is a concrete that is completely out of normative system against the earthquake that we have today in Italy, and is also a museum that for 70 years was completely without plans for ventilation and for filtration of air. And that's produced a lot of problems to you know, to the archaeologists and to the special archaeology elements shown in the museum. So the idea was to realize a central strat, let's say, that produce in all the perimeter of the existing courtyard, no, and rigid element, and internal of this new element, realization of all the line of the plans, but also the realization of a system that, thanks to the fact that the top of the courtyard is completely closed with glass, with glass that is the floor of the new cafeteria on the top. Thanks to the fact that this is glass, and thanks to the fact that there is a lot of insulation, we are in Reggio Calabria, there is production of warm air, heating that goes out through this new simini that is realized with the enlargement of the walls, that ask again for fresh air that goes from the basement, let's say, where the air is 15 degrees less than the internal. So there is a continuous loop produced thanks to the insulation that ask for fresh air becoming from basement, let's say. This is the top with the new cafeteria and a shelter that reduce the insulation, of course. Then the big problem for this museum was to realize that, a structure almost invisible. Because the problem, as you can see here, is that because this is 20 meters, 15 meters, sorry, and the dimension here is 30 meters. So beams necessary to realize the floor was anyway important, huge. So the idea was to try to realize this incredible structure studied from Buckminster Fuller during the 30s. And the name of this structure is tensegrity. A tensegrity, more or less, is a spatial reticular structure in that any element that is under tension, any, let's say, strap or any tensor, is transformed in a cable, okay? It rests as a visible element, like in a huge pincushion, let's say, no? It rests only the element, the strut, where is compression, okay? So the imaging that you obtain is an incredible light and extremely incredible, no, structure, like a pincushion, let's say, no? In that there is a continuity of tensors, of straps, and the discontinuity struts. Okay. This is the realization that is quite particular, but this is actually it's somebody explained to us that actually this is the tensegrity, the biggest tensegrity never realized in a building, but the reason because the original tensegrity, yeah, like oh sorry, like this, no, that is the Buckminster Fuller tensegrity, never was used in buildings. Is that, you know, the tensor that are cable, let's say, in steel, they have a very high epsilon. That means that you know, the under the sun, under the tension, there is an enlargement of the cable that produce a losing of tension and produce a collapse of the structure. In this case, we realized the cable in carbo steel that have an epsilon extremely reduced without enlargement, and that's the reason because they stay up, okay? Because otherwise it was almost impossible to obtain this realization. Realization was the original courtyard is the new lobby of the museum, and he's very particularly decorated, let's say, with this fantastic installation of a very important artist, Italian artist, that is Alfredo Pirri, that use, let's say, the typical material of the architects that are plaster panels that he paint on the back, realizing, as you can see here, an movement of red shadow. But because the shadow are continuously in variation, thanks to the fact that the sun goes like this, if you stay here for 5 minutes, you can see an dynamic condition of the movement of the red shadow, no? And very, very particular. Yeah, this is the condition of the tensor structure of the tensegrity. If you look at the tensegrity from the bottom, you see completely transparent. If you look in transversal, you can see the pincushion. No? We also reformulated, renovated all the visit way and the exhibition boxes. Special particularity of this, it's this glass, in stratification have this simple element lead, like a rice piece, no? And so the light go down from nothing, you know, from the glass, and produce no shadow. That it's a big problem for the exhibition boxes usually. No? And at the end also, let me say that with the morphology, with form, we obtain a solution. With morphology and creativity, we obtain a solution to the problem of anti-earthquake of the basement of the Bronzi. This is the two statues, the two bronze famous for the museum, Bronzi di Riace, fantastic bronzes. And they ask for a basement for an anti-earthquake basement, because the idea is that, okay, building now is under security, let's say, but if earthquake start, the risk is that the bronze go down and collapse and produce damage of the bronze. So please make also a basement of the bronze that is anti-earthquake. So the idea was to realize something that through form, to morphology, solve the problem, to creativity, solve the problem. And as you can see, the basement is realized, it's 150 for 150, 30 centimeter and 20 centimeter of Carrara blocks, but they are splitted, and in the middle are 1, 2, 3, and 4 balls, spheres of Carrara of 10 centimeter, but they are spheres are inside of, let's say, a spinful that we realized both on the basement and on the top, okay, for 4 times. So when this is the test that we have for the basement, when the earthquake start to move the under basement, but the upper basement stay completely firm, no? Thanks to the fact that the balls go like a crazy, but never out from the spinful, let's say. So this is the glass over the the tensegrity, and this is the Stretto di Messina, and in front of us there is the Sicily, okay, with the original bridge of Pier Luigi Nervi, that you can see here how long will be the idea of the bridge. The last project that I want to show you is the our project for that is still now under construction. That is the project for the Obra Lyric Theater in Firenze. Yeah, in fact, this is the presentation 10 years ago, and this is Zubin Mehta, that was our client, let's say, in certain sense. The idea is something that transforms itself thanks to the light between night and day. During the days, it's very simple marble, and but during the night, to transform itself in a huge lamp, let's say, you know, in a urban lamp, let's say, thanks to the simple skin of this. This is cotto fiorentino that we use suspended and 60 centimeter over the wall, let's say. Okay, and yeah, this is the arena that is for 2,300 people that go up and produce this incredible view of the center of Florence, like an hill, let's say, an artificial hill. Thanks to that, it's possible to look in a very eccentric way out of the center, let's say, you know, the center of Florence. Again, the idea to use materials for recontextualization, in particular, in this case, we used in this very modern form of the concert of the, sorry, the Opera Lyric Theater. We used the marble, yeah, of Marmo Cipollino, that is the marble of Battistero di Firenze, and this incredible back of the main room that is golded painted, but it's not a paint. It's like a bell, like a bronze bell, but it's not bronze, but it's gold, and it's the gold of l'oro dei Medici. Is exactly the gold becoming from the rooms, Medici rooms in Palazzo Vecchio. Yeah, this is the bottom, let's say, of the main room. Main room is very particular, because the idea also in this case is to obtain true forms and true creativity, something that optimize acoustic answer, like in an musical instrument, through the form, not through correction panel, let's say, no? But simply through forms, okay? Like in a violin, in the optimization of tonality, it's thanks to the form of violin. So final result is this one. Acoustic engineer was Jürgen Reinhold, that was an acoustic engineer from Germany, and was very exciting to work together, integrated with between architecture and engineering. In this case, of course, the problem is that the tool that we have in our hand, this form, have to attain at the end not only optimization only of the acoustic, no, but also of, you know, fireplace, of fire normative system, of structures, of view, because this is not a concert hall, but the Opera Lyric Theater. So it's necessary for any singular element to obtain. Also very particular, as you can see here, is this kind of form of solution, let's say, for the palchi dell'opera. And that became from the asking of Zubi Meda that asked us to obtain something, a solution without, let's say, without railing, without parapet, no? Because he said for musician, the idea of vertical element, it's every time is an obsession, because we think that music go to the vertical railing and reflect itself. So please produce something to eliminate it on every vertical railing, let's say. And this is the solution, no? Like in ice cream box with a spoon, we produce a spoon fill like this, and we put the chairs, and this is the solution. Yeah, that's it. Thanks a lot.
Paolo, thank you. That was an excellent lecture. It's gave us a great feeling for the great engineer, architect, Pier Luigi Nervi, and your history with that office. And you know, the first time I saw your work, you know, going on your website is one thing, but hearing you speak about the great work that your office is doing right now, it's up there as one of the, you know, the great offices of the world. So we're grateful for you sharing your experience and the projects that you've done and are still currently under construction, including the last one that you've shown.
Silvio, there are a couple of questions that we can share.
Yeah, so I'm just gonna, so with that, I'm going to turn it over to John, who is going to ask you a few questions from our audience. So with that, I'll turn it over to John.
Thanks, Silvio. So Paolo, the first question is going back to the earlier part of the presentation about Nervi's work. So yeah. I'm just going to read it because it's very nicely phrased. You and Silvio have emphasized how Nervi's work is a brilliant conflation of engineering and architecture, the firmitas and utilitas of the Vitruvian triad. But watching your presentation, we're struck with its venitas, how astoundingly beautiful it is too. So how consciously did Nervi consider pure aesthetics in his work?
Nervi wrote two very important books. One is Scienza o Arte del Costruire. And in this book, it's extremely clear that Nervi doesn't accept any specific approach to the aesthetic as an autonomous discipline. Was very clear in Nervi position that form is not calculation, not mathematic, you know, not model, not structural model, but form is the main tool. But to obtain this as a designer, it's necessary to accept the idea that form are not an autonomous discipline, let's say. It's unacceptable, the idea to obtain a thinking regarding forms or aesthetic, without any problem to solve. So in this sense, let me say that for sure there is not an aesthetic in Nervi without not function. It's not a problem of function. It's a problem of problems to solve. Let's say it's a problem to solve. Without problems to solve, let me say that Nervi contribution, it's not so smart. Let me show you something here that is, in my opinion, very clearly. Yeah, look at this. So it's absolutely clear that form, no? Can you see my mouse?
Yes.
Yeah, okay. It's very clear that form obtains solution from the cubo and in every this point here. But for this one, there is no strictly sense to the form. And Nervi accept to realize this strange element that remember to me the old lamps that stay in our kitchen. Very bad, very, very simple. And the reason is that Nervi has no problem to solve here. And at that point, you know, he has to invent an autonomous aesthetic, and he fell down. Without problem to solve, there is no possibility to have any creativity, let's say. Let me say again that there is another important element that, let me say, the way that Nervi proposed is a joke. My next sentence is a joke, but the way that Nervi produced is very simple way, because he offer a strategy to solve through creativity solution mainly to one problem, that is the structural one. But if you want really to use the idea of Nervi, let's use creativity. Let's use creativity to solve problem. We have, I think personally, that we have to use this sentence for any problem that we have in front. Problem of urbanistic? Yes, of course. Problem of contest? Yes, of course. Problem of cost? Yes, of course. Problem, anyway, creativity. Not only structure, but not only construction, let's say, no, but in general, any approach can be under this strategy, and this is more and more complex than in Nervi proposition, let's say.
Thank you. We do have a couple of questions that are, I would say, more along the line of process-oriented questions. So this is, again, I'll read. I think this came up right around the time of when you were showing your train station, which, you know, the sort of scale of it is impressive, and its effect in an urban area. So these are incredibly elegant structures, obviously driven by the simplicity of materials and physics. How does your firm address the engagement of the wider community in these large-scale projects? In simple terms, how do the users of the facility embrace the design?
Sorry, that's in Tiburtina Station or in Casablanca?
I think it came with the Tiburtina Station, I believe.
Okay.
As a question, it might apply to both. I think it's, as I said, a general process question.
The question is how to decide materials.
I think this question has to do with how do you engage the wider community in the process of design that creates, you know, such important urban interventions.
Well, it's a very complicated question for this huge infrastructure design. There are a lot of design from the office that had a confrontation with the local community. In this case, let me say the main confrontation, also because the dimension is so huge, and the site is in certain sense so out of the city, no, because this is a bridge that is in the middle of nowhere. City is here and city is here, but never city was and will be here, because this is the site of infrastructure, is the site of no. So that's the reason, because the confrontation in this case, I think it's with let's say actors that in administration have to check and represent local communities in administration approval process. Imagine that this project here was under confrontation. The process in Italy, we say Conferenza dei Servizi. Conferenza dei Servizi is like in a Kafka in a Kafka book, a confrontation between the designer and all at same time, at that same table, all the actors involved in approval. So for more or less 1 year, I have in front of my 8 months, not 1 year. For 8 months, I have in front of my 36 actors, 36, because, you know, Comune di Roma, local administration of Rome, is not just one, but is more or less 10 or 12, because it's the alderman of urbanistic, the alderman of public works, the alderman of commerce, the alderman, no? And then there is the soprintendenza, that is the commissioner for Belle Arti, and then there is the state, and then there is the banks, and then there is, so any one of them asking to the designer condition that are in conflict one over each other, because the asking of the transport alderman to obtain for any singular street the maximum of dimension, to have the maximum of fluidity for the buses, is absolutely against and in conflict with the asking of the alderman of boys and girls and family representation, that ask that any singular piece of land is largest and largest and largest possible to have place for boys, you know. And so, and every one of them ask with this conflict to the project to create, thanks to the project, a balance, an equilibrium, let me say, a miraculous equilibrium between the conflict. in large infrastructure project, there is a spectrum of conflict that the project have to balance through the forms, again, with Nervi, we can say through creativity, but it's a very enlarged idea of using creativity. No? And at the end, you know, or you won the challenge to obtain, you know, the balance between the different position, or your design died.
There's a number of other questions that are sort of, again, relating to sort of process, design process. I think about how does a design of such clarity of form, you know, and I think some of us are you know, imagining you know, a situation in competition where that form gets, you know, in some ways developed at a relatively early stage, yet its real power is in the relationship between your work and the work of others, the engineers on your team and the like. So how does that process happen to get to such, in your mind, to get to such clarity of form when you have to, you know, when so much relies on you know, a process of working with others to make it happen?
It's a good question. It's a complicated question. Let me say that seems to me that more and more and more our job, our profession as a designer, no, it's not important if we are engineers or if we are architects. There is anyway there is a main designer, a coordinator, let's say, a conductor. No? That could be an architect or an engineer, a civil engineer. Or, no, it's not important. But anyway, a conductor, let's say. No? And in this case, coordination. You know, there is a table of coordination that start and produce decision. And it's important to understand, like a musical conductor, no? To understand and to play any instrument, because otherwise, if you are not able to play any singular instrument, a little bit, let's say, not like a virtuoso, but a little bit violin, a little bit clarinet, a little bit piano, a little bit, no? Immediately there is a player that say, oh, okay, come on, that's impossible. You can do that. So every time I say to my students, you have to be more clever than a structural engineer, because he has to understand the limit of them and accept or not. No? But at the end, in my opinion, every time the solution is through this very important tool that is the form, the final morphology, that is the project, let's say. In this table, the rule of the architects, it's something that disappear or you know, overlapped anytime with the specialist. There is a very important sentence of Bruce Graham, the fantastic architect of Skidmore, Owings and Merrill, that was the chief architect in Chicago. And Bruce Graham wrote that during the 50s, we was under reconstruction. Every time we start the daily meeting with all the engineers of the company, they was the priest of our knowledge and the Vestali. I don't know the translation, but Vestali are the female priest of our competence.
Beautiful.
Without engineers, there is no possibility for architects. There is only masturbation, let me say. No, but without architect, no, there is no way for engineers, because there is no, without architects, let's say, without chief chief conductor, let's say, you know, there is no calculation that produce solution. Nervi every time says that to be a good engineer was sufficient to have capacity to add, to multiply, to divide, and to use minus. So the 4 operations, you know, and that's it. And I was very young, but because the Nervi was, of course, the chief in my father's studio, my father's office. But every time that I was child, I was so lucky to find Pier Luigi in the office, no? And he was full of sentence, also for boys like me. Yeah.
Thank you, Paolo. I think, Silvio, would you agree that we're just about out of time? Do you have, would you like to give the final thanks?
I would agree. I think that that's a great place to end this. I think, Paolo, I mean, the lecture was fantastic. It was everything that I think that everyone that's on the line for NORR Ed would have wanted in a lecture like this.
I'm sorry for my gesticulate English, but
no, your English was perfect. I think you know, obviously having known Pier Luigi Nervi is incredible, and having to lived through that era is quite incredible. Having listened to this lecture, I don't know, I wish I'd gone to your university and studied under you. That would have been a real pleasure, and I would have been able to live in Italy, which might have been even better. But
yeah, for sure, we wait.
I want to sincerely thank you on behalf of everyone that's on the line. This was great, and hopefully we will see each other in the near future when all of this mess is over, and hopefully be able to have you back again at some point in time. So thank you again. Ciao. Ti abbraccio.
Grazie. Ciao.